Our two contracts are now looking pretty good. We're going to start on the front end application here in just a little bit, but first I want to write some tests around both the campaign factory and the campaign. We're going to set up a testing framework just like we have on previous videos with other contracts that we've worked on. I'm sure by this point maybe you're a little bit tired of writing tests. Nonetheless, I really encourage you to give writing these tests a little bit of a shot because it'll give you more experience with working with the Web3 library. So in this video, we're going to start doing the setup for our testing environment. We're going to take a slightly different approach than we did previously. We're going to have a little bit different file and folder structure because we're going to eventually turn this next project that we're working on into the front end as well, just like we did on the last application. All right, so let's get started. Over at my command line, I'm going to make a new project directory. So here are some of the other projects we've worked on up to this point. I'm going to make a new project directory and I'm going to call it Kickstart. I'll then change into that directory and then I will generate my package.json file by running the npm init command. As usual, we're going to hit enter a whole bunch and eventually get dumped back at the command line, like so. Next, we're going to install a couple of different packages right now from the get-go. So we're going to do an npm install -- save. And like I said, we're going to do maybe 4 or 5 different packages this time. First, we'll get Ganache CLI. We'll get Mocha. We'll get the Solidity compiler, solc, so SOLC right here. We're going to get an extra module this time called fs-extra. And I think the last one that we probably need right now is Web3. And remember, we are using a very specific version. So Web3 at 1.0.0-beta.26, like so. All right, so let's install that and let it do its thing. It's going to take a minute or two for this to install. So we're going to pause right here and come back in the next video and start using these modules for our new testing setup. In the last section, we installed a bunch of different modules into our new Kickstart project. We're now going to move ahead by creating a couple of different project files and folders inside of this Kickstart directory. I'm going to start up my code editor inside of here, and then we're going to make a couple of different files and folders. Before we do, I want to remind you about how we structured some of our previous projects. So here's my code editor inside of the Glossary project that we had worked on previously. Inside of here, we had the compile script, the deploy script, the contracts directory, and the test directory. And they were all in the root project directory. For this Kickstart project that we are about to work on, we're going to end up with a lot of different project files and folders. And some of it is going to be related to the Ethereum side of our application, and other portions will be related entirely to the web side of things, or the actual web application that we're going to build. In order to better organize the files and folders inside of our project, I think that rather than locating, compile, and deploy and contracts and all this stuff in the root project directory, I think we should make a new folder inside of here and have that contain all of the Ethereum related code that exists inside of our project. That'll make it a lot more obvious where the React application starts and where the Ethereum side of the application starts. So with that in mind, I'm going to find my Kickstart directory and I'll make a new folder inside of it. I'm going to call this folder Ethereum, because it's going to contain all of my Ethereum related code. Then inside of here, we can make some of our different project files and folders that we know that we're going to need. So I know for sure that I'm going to need a compile.js file because we're going to eventually want to compile our contracts. I know for sure that I'll want a deploy script. So I'll make deploy.js. And then I know for sure that I definitely want to place my contracts inside of this thing as well. So I'll make a contracts folder. Finally, inside the contracts folder, I'm going to make one more file, and this one is going to house our two contracts, both the campaign contract and the campaign factory. So I'm going to make campaign.sol, like so. Now the last thing we need to do is go back over to Remix. We're going to copy all of our contract code and dump it into this file. So I'll go back over to Remix. I'm going to select everything inside the editor. I'll copy it, and then I'm going to go back over to the campaign.sol file and paste it. And definitely do not forget to save the file. Very important part. All right, so this looks good so far. We're going to take a break right now, and we'll come back in the next section and start working on our deploy and compile scripts. In the last section, we made a couple of different files and folders inside of our Ethereum directory. We're now going to start working on our compile.js file. Before we start writing any code in here, I want to remind you how we did things previously back on our lottery project. So back on the lottery project, we read in the lottery file with read file sync right here. We then took the contents of that, fed it into the Solidity compiler, and then we eventually exported just the lottery contract from this file. There was a very big downside to this approach right here. And the downside was that every single time we started up our project, either to run some code or run our tests or whatever it was, we always had to recompile the entire contract. So this time around, I don't really want to wait those 3, 4, 5 seconds for our contract to start up. Instead, I want to compile our contract one time, write the output to a new file inside of our project, and then access that compiled version. So in other words, rather than compiling every time we start our project up, I want to compile one time and write the output to a file that we can then read in the future. So with that in mind, our compile file is going to look a little different than it did previously. There are going to be a fair number of steps that we're going to go through in here to implement this new compile flow. So let's first walk through those steps, and then we'll start adding some code to the compile file. Now, the first thing I want you to be aware of here is that we have one single campaign file contract, but inside there we have two separate actual contracts. When we feed this one file into the Solidity compiler, we're going to eventually spit out two separate files. So one file is going to contain the compiled campaign, and the other is going to contain the compiled campaign factory. So we want to take both these output files and save them both to our project directory somewhere. And the real question then is, hey, where are we going to actually save them to? So here's a diagram with our Ethereum folder. Inside there, we have the contracts folder and we have the compile.js file. I'm going to propose that maybe we should make a new folder inside of the Ethereum one. And maybe we should call that something like build. And we can place all of our compiled contracts into this build folder. Then we can put some logic together inside the compile.js file that goes through these steps right here. So anytime we run this compile script, we'll go through these steps. So let's walk through them very slowly, or very quickly, either one. So the first thing we're going to do is to delete the entire build folder from this compile.js script. This might be a little bit mysterious right here, but remember, the idea is that we should only be running our compile script one time now. And then we should be able to run our application as many times as we wish without having to wait for the Solidity compiler to run again. So if we ever run the compile script more than one time in a row, that definitely probably means that we are making some very active changes to our contract. Like we are changing our contract directory or the contracts that sit inside this folder. So if we are changing our contracts, we very likely want to throw away all the previous stuff that we had compiled before. We don't want any old or outdated code sitting around. So the first thing we're going to do inside this compile.js file is to delete that entire build folder if it exists. After that, we'll reach into the contracts directory and we'll read the contents of the campaign.sol file. So this is very similar to what we were doing before when we were reading the contents of the lottery directory, or excuse me, the lottery file. Next, we will compile both the contracts inside that file with the Solidity compiler. And as we just said a moment ago, the output of that is going to be the compiled campaign and the compiled campaign factory. And these are two separate objects, two separate files that we want to deal with. So we're going to take both those outputs and write them both to the build directory as JSON files. Then anytime in the future when we need to access the ABI, remember that's the interface, or the bytecode of our contracts, we can read them from this build directory without having to actually recompile any of our contracts. Okay, so that's the idea. Let's take a pause, come back to the next section, and we're going to start to integrate this script into our project. In the last video, we spoke about the compile script that we're about to put together. Let's now change over to our code editor and start writing it out. I'm inside of my compile.js file. At the very top, we're going to import a couple of different modules. These are going to look very familiar because we already required a lot of them into the previous compile script that we had put together. So we'll say const path is require path. I'll pull in the Solidity compiler. And then finally, I'm also going to pull in the fs module. But this time around, we're going to make one small change. So I'm going to say fs is require fs-extra, like so. So in the past, we were working with the fs module. Remember, this is a part of the Node standard library. It is short for file system, and it gives us access to the file system on our local computer. We're not using fs this time though. Instead, we are using a community-made module called fs-extra. fs-extra is very similar to the fs module, but it has, as you might guess, a couple of extra functions tied to it. So in other words, this is kind of an improved version of the fs module that has a couple extra functions that are going to save us a lot of time as we start writing some code inside this file. So basically, it's the file system module, just a couple of helpers. All right, so now inside of here, the first thing we're going to do is start putting together some logic to delete the entire build folder if it already exists. So at the very top, we're going to first get our path to that build folder. Now the build folder doesn't exist yet, but we can eventually imagine that we will have a folder inside of our Ethereum directory called build, like so. So I want to get a reference to this folder right here. To do so, we'll use the path module along with the resolve method on it. So I'll say const build path is path.resolve, and then we're going to take our current working directory by using __ name. Remember, there's two underscores right here. So that gets us into our Ethereum directory. And then to actually run the build script, we'll pass in a second argument that is a string of build. Then with this reference to the build directory, we can call a function on the fs module to remove that entire directory and everything inside of it. So we'll write out fs.remove sync build path. Remove sync right here is one of the improved or kind of extra functions that is included with this fs-extra module. The default or standard file system module that is included with Node doesn't have the ability to easily remove one file or one folder and everything inside of it in a single command. If you want to use the default fs module, this gets a lot more complicated than what you see right here. So remove sync just looks at this file, or excuse me, this folder, and deletes it and everything inside of it. Okay, so now after that, we can start doing the next step on here. So we need to read in the campaign.sol file from the contracts folder, very similar to what we were doing before. So first, we'll get a path to the contracts directory. And excuse me, not the contracts directory, but the actual campaign contract file. So I'll say campaign path is path.resolve, and then we want __ dir name, contracts, and then the actual file name, which is campaign.sol, like so. Next, we're going to read in the source code from that file. And again, this is going to be very similar to what we did previously on our lottery project. So I'll say const source is fs.read file sync. We'll pass in the campaign path and then specify the encoding of that file, which is UTF-8. So we've now got the contents of the campaign file. Next, we're going to use the Solidity compiler to compile everything that we just pulled out of that file. So we'll say const output is Solidity compiler.compile, and then we're going to say source 1, and the only property that we care about that is coming off of this compile process right here is the contracts property. We don't care about any other output from the compiler. The only thing we care about is the contracts that we just compiled. So we're going to pull off the contracts property and assign that to output, like so. Now the output variable right here contains two separate objects. One object is the output from compiling our campaign contract, and the other is the output from compiling the campaign factory. So we're going to eventually loop over this campaign thing right here and then write out the contents of it to two separate files. Before we do that, however, we do need to make sure that we create the build directory. So remember, up here at step 1, we deleted the entire build folder, including the actual folder itself. So before we start trying to write any output to the build directory, we have to recreate that folder. To create that folder, we can write fs.ensure dir sync. And then we can pass in the build path that we had created earlier. Ensure dir right here, or ensure directory, checks to see if a directory exists. And if it does not exist, this function will create it for us. So essentially this line of code is going to create that build folder. Now the last thing that we're going to do is loop over this output object. We're going to take each contract that exists inside there and write it to a different file inside of our build directory. This part is going to be a little bit more complicated, but we'll write out the code for it, and then as soon as we run this code, it'll be really obvious exactly what's going on. So let's write out the code and then we'll talk about what it's doing. I'm going to say for let contract in output. Then I'm going to call a function off the fs module. I'm going to say fs.output JSON sync. I'm going to call that function and we're going to pass in two separate arguments. These two separate arguments are going to be a little bit long, so I'm going to give myself a little bit of space to type. I'm going to say path.resolve, and I'm going to build the path to the file that I want to save this to. So I'm going to pass in build path and then the actual file name, which is going to be contract. So this is the name of the contract that we just pulled out of this output object, and then I want to make sure it has a .json file extension. So I'm going to say contract plus .json. And then as a second argument to the output JSON sync function, I'm going to write output square braces contract, like so. Okay, so I know this is a nasty little piece of code right here. I know this looks pretty nasty. Let's first run our compile script. We're going to verify that it works the way we expect, and then we'll talk about exactly what this for loop is doing for us. And we'll also print out a couple of different steps inside of here using some console logs so we can get a better idea of what's going on. So to run that script, I'm going to go over to my terminal. I'll change into the Ethereum directory, and then I'm going to run node compile.js. Now with any luck, we're going to wait a second or two, and then we should get kicked right back to the command line. Okay, so I got kicked right back to the command line. But if I go back over to my code editor, I can see that I have my build directory, and inside there, I've got two JSON files. One is campaign.json and the other is campaignfactory.json. Notice that there is a little colon in front of each file name. We'll fix up that colon in just a second. But first, let's take a break. We'll come back in the next video and we're going to break down this for loop that we just wrote right here. So I'll see you in just a minute. In the last section, we put together our compile script. We got down to the very bottom here and we wrote out a kind of nasty for loop. So I want to clarify exactly what's going on inside of here. First, right above the for loop, I want to add a console log statement, and I want to log out the output object. Remember, output is coming from the Solidity compiler. Let's now save this file, we'll rerun the script, and we'll get a better idea of exactly what output is. Back at the terminal, I'll again run compile.js. Now we do have to wait a second or two for the Solidity compiler to run. The good news is that this is a pause that we will not have to wait for when we start actually building our project. It's really just a one-time wait. All right, so here's our console log. Now if I scroll up, you're going to see everything that we saw before that represents our outputted contract. If I scroll up enough, and it might take just a second to actually find it, but somewhere in here, somewhere, lo and behold, here we go. So the object, or the thing that we just console logged, is an object that has two separate properties on it. The first property is : campaign factory. This is a key that references all the output from our compiler for the campaign factory contract. If I scroll up even farther, we'll eventually see another similar key for our campaign contract. And here it is right here. So you can see we've got an object. We are definitely working with an object, and it has a key of :campaign and :campaign factory. So back inside of our code editor, the for loop might make a little bit more sense right now. This is a for-in loop. A for-in loop is used to iterate over the keys of an object. So we are iterating over both the campaign factory contract and the campaign contract. The key that we were just looking at will be assigned to this contract variable. And when I say key, I'm talking about this string right here. So contract, that contract variable, is going to be either the string :campaign or :campaign factory. So then inside of the for loop itself, we call a function called output JSON sync. Output JSON sync, you might have a pretty good instinct of what this thing does. It's going to write out a JSON file to some specified folder inside of our directory. So we are passing in a path to the build path, and then specifically a file inside there that we are calling contract plus JSON. So maybe now it makes a little bit more sense where this colon right here is coming from. We have a colon in the file name because we are using this key right here, and the key itself has a colon in it. We then append on the .json extension so that we very clearly label what type of file this is. The other thing that might be a little bit unclear is the second argument to this function, the second argument to output JSON sync. The second argument is the actual contents that we want to write to this JSON file. So if we reference back to the output object, which is this entire big console log thing right here, so we are referencing this entire big object, and we are trying to pull off either the :contract or :contract, or excuse me, :campaign or :campaign factory. And we write out the entire thing using output JSON sync. If we open up either one of these files, you'll see all the JSON contents that we just saw over at the terminal. So here's like the assembly property. Somewhere inside of here, you're going to see a bunch of other related stuff as well. Like here's all the instructions. We just saw the bytecode like right here. Yeah, runtime bytecode. So basically it's all inside of here. All right, so that's pretty much the compile script. Now I do want to do a little bit of cleanup here. I want to clean up that console log. And the other thing that I'm thinking, we don't really want to have a file name with :campaign. So I think that before we create the actual file name right here, we should do contract, and then we should subtract or remove the colon from that thing. So on contract, I'm going to say .replace, replace, and I want to replace the colon character with empty string, like so. By the way, if you want to use a little bit of ES 2015 syntax right here and use a template string instead of using string concatenation, that's totally fine. You could definitely go ahead and do the refactor. But I think this line of code is already confusing enough, so I'm just going to leave it as is. All right, now here's the moment of truth. We just made a change to our compile script. So the output that I expect to see now should not have a colon. So I now want to recompile our contracts. And when I do so, I want to make sure that the existing code or the existing files I have inside there get completely blown away and entirely replaced with this new version that does not have the colons inside of it. Remember, that's the entire idea behind this compile script. Anytime we make a change to our contract from here on out, we should be able to rerun the compile command and be 100% confident that only the most up-to-date version of our contracts exist inside the build directory. So back at the terminal, let's rerun the node compile.js command. And then we should be able to look inside of our build directory and verify that the old files that we just created got blown away and completely deleted. Okay, so back over here, and I can see inside the build folder, yep, it looks like the colon is completely gone. So that definitely means that we are deleting everything inside the build directory and then replacing it with this newly compiled version of our campaign and campaign factory. So this is looking pretty good. let's continue in the next section, and we're going to get started on writing some tests around our campaign contracts as well. We just finished up our compile script. We're now going to start writing some of the different tests for both our campaign and campaign factory contracts. To do so, I'm going to create a new folder inside of my root project directory called test. Now this might be a little bit of a surprise, the fact that we're putting this test directory in the root project folder. You might be thinking, Stephen, this is testing for the Ethereum side of our application. Shouldn't we put test inside of the Ethereum folder? Well, to be honest, this is something that's probably very debatable. You see, inside of our overall project, we might end up with a bunch of different tests. And some of them might be related to the Ethereum side. Others might be related to the web application side. Me personally, I think that all of the different tests that we have for a single project should all be put in the same location, rather than scattering them all out throughout our project. So personally, I think that the tests for our Ethereum contract should definitely go in this root project directory, because if we end up writing tests for the web app side of our application, we're definitely going to want to place them in here rather than nesting them inside of the Ethereum directory. So that's the thought process. With that in mind, I'm going to open up the test directory and I'm going to make a new file where we're going to write all of our tests for our campaign contract. campaign.test.js. Even though we have two separate contracts, I'm only going to create one single test file. The reasoning behind this is that, the two contracts we have are so incredibly closely related that I think that it kind of makes sense to just keep them all in the same test file. In addition, there's not really a lot of stuff that we have to test around the campaign factory itself. The campaign factory really just does two things. It deploys instances of the campaign, and it retrieves a list of all the different instances it has deployed. Those are two tests that we can very quickly merge directly into this campaign.test.js file. All right, so inside of here, let's start writing out some of our boilerplate for putting together a test file. This is going to look very familiar, very similar to some of the testing setup we did previously. So at the top, we'll pull in the assert module. We'll pull in the Ganache CLI. We will pull in the web3 constructor. So notice this has a capital W right here, capital W. And then we will right away make an instance of web3. So lowercase web3 is new capital web3 ganache.provider, like so. Next, we're going to require in the two compiled versions of our contracts. So I want to require in both the campaign and the campaign factory. So I'm going to say const compiled factory is require, and this is going to be a little bit tough because we're going to have to provide a directory that walks from the test folder, or specifically the campaign test file, up into the Ethereum folder, build, and then campaign factory.json. So we're going to do .. to get out of the test directory, then Ethereum, build, and campaign factory.json. So there's the entire path. This is going to require in the entire module or the entire file. So everything that exists inside that JSON file. This is a little bit different than what we did previously, where we only imported in the interface and the bytecode properties. This time, we're just going to pull in the entire thing. Next, we're also going to require in the campaign itself. So const compiled campaign is require .. Ethereum build, and this time it's going to be just campaign because I want just the campaign.json file. So campaign.json, like so. All right, now that we've got these, we'll put together our before each statement, and inside there we will use our account to deploy a new instance of our factory. And then we can manipulate that factory and start creating campaigns and writing tests around it. Before we write the before each, we're going to declare a couple of reusable variables with the let keyword. We're going to end up with 4 different variables here. So we're going to say let accounts. Accounts is going to be just what it was before, a listing of all the different accounts that exist on this local Ganache network. we'll do let factory. This is going to be a reference to the deployed instance of the factory that you and I are going to make. And then we're going to do two others, and I'll tell you exactly what these are when we start writing some code around them. I'm going to say let campaign address and let campaign, like so. Then we can define the before each. So I'll say before each. I'm going to make sure, 100% sure, that I mark this as async. And then inside this function, we'll get our list of accounts just as we did previously. And we're going to then deploy an instance of our factory contract by using the compiled factory right here. We've gone through this process many times so far throughout this course. Remember, we're going to use the contract constructor that is a part of the web3.eth library. And then we're going to pass in our compiled factory's ABI, or its interface. We will then deploy it and send the transaction out to the network. So 3 separate steps. So we'll say factory is going to be await new web3.eth.C contract. And then we have to pass in our compiled factory ABI. So it's the interface property off of compiled factory right here. Remember that when we pull that property off of compiled factory, it will be JSON, but this constructor right here does not expect JSON. It wants to see an actual JavaScript object. So we have to parse this thing. So we're going to say json.parse compiled factory.interface. Okay, just 2 more quick steps. This creates the idea of the contract inside of Web3, but now we have to actually attempt to deploy it. Because we're not working with an existing instance. We're trying to deploy a new instance of our factory. So we're going to chain on a .deploy. Remember that the .deploy statement right here receives the actual bytecode that we're trying to deploy to the network. And we provide that on the data property. So we say in an object, data is compiled factory.bytecode. And then the last step, we're going to write out the actual sending of the transaction. So we do .send. We have to specify which account is going to attempt to deploy this. So we'll use accounts at 0. And remember, we just fetched our accounts a second ago with the get accounts. And then we also have to specify the amount of gas that we want to spend. So gas, and just like before, we're just going to arbitrarily say 1 million. And of course, not use the commas. I just put them in there so you can very clearly see that it is 1 million. All right, so we've done a lot of typing in this video so far. Let's pause right now. When we come back in the next video, we're going to talk about why we created these 2 variables, campaign address and campaign. So quick break, and we'll keep on going. Our before each statement is looking pretty good. We have our list of accounts, and we have deployed a factory. We had created these 2 extra variables as well. So let's now talk about why we made these. The purpose of this campaign test file is to eventually test our campaigns, right? Yeah, we want to test the factory inside of here as well, but mostly we probably want to test a campaign. It probably makes sense that almost every single test that we're going to end up writing is probably going to end up needing an instance of a campaign. So rather than using the factory inside of every it statement to create a separate instance of a campaign, I think that we should probably just make one campaign from the get-go inside the before each, and then we will have it available inside of every other it statement inside this file. So it's going to save us a lot of typing from having to constantly use the factory to make an instance of the campaign. So with that in mind, maybe the purpose of these 2 variables is a little bit more clear. We're going to now use the factory to create an instance of a campaign and assign it to the campaign variable. We'll also take the address of that thing and assign it to the campaign address variable as well. Okay, so let's get to it. So we're going to use the factory to make an instance of a campaign. So inside the before each, at the very bottom, we're going to call the create campaign function on our factory that we just made right here. Of course, anytime we call a function, it's always going to be asynchronous. So we're going to make sure that we lead off with the await keyword. We'll then reference factory.methods, and specifically we want to call the create campaign function. So we'll say create campaign, like so. Remember that create campaign requires exactly one argument. It's supposed to be the amount of money that is going to be the minimum contribution. So here's my campaign factory, here's the create campaign function. We are expected to pass in the minimum contribution. So for the purposes of this test, I don't want to have to deal a whole bunch with dealing of conversion between Wei and Ether or anything like that. So I'm going to say that the minimum contribution is going to be simply 100 Wei. Again, you'll see that I'm representing a number here as a string. I know that we still have not quite gone into great detail on why that is, but certainly on this application that we're going to work on in just a little bit, it'll be a lot obvious why we're using the string here. So we call create campaign, we place our one set of parentheses, and then don't forget we have to also specify whether or not we are doing a call or a send to this function. In this case, we are trying to modify data inside of our contract. Heck, we're trying to deploy a new contract. So without a doubt, this is going to be sending a transaction because we're trying to modify some data on the blockchain. So I'm going to say .send, and then we're going to specify who is sending this transaction and the amount of gas to use. So the person sending the transaction, just like before, we'll say it is accounts at 0. So accounts at 0 is going to be the manager of this campaign. Then we'll also specify our gas. And for that, we'll again do 1 million. All right, so this definitely creates the campaign right here, but we do not actually have a reference to the campaign. Remember, anytime we call send, or anytime we send a transaction, we get absolutely no result back, except for a transaction receipt. So we have absolutely no idea what address the campaign was just created at. That is exactly why we had created that other function on the campaign factory. So here's campaign factory. You'll recall that we made the get deployed campaigns function. And this is how we get access to any of the campaigns that have been created with the factory. So in order to get access to the campaign that was just made, we have to call that function and read off the address. So on the next line down below, we're going to call the get deployed campaigns method off of the factory.methods object. As usual, yep, it's asynchronous, so don't forget to put down the await keyword. By the way, at this point, could you even possibly imagine doing this without async await? That just kind of occurred to me right now. Could you imagine if we were using callbacks for all this stuff, or if we were using promises even? I can't even remotely imagine writing this code using promises, let alone callbacks. That would be so awful. Anyways, back on topic. So we're going to use factory.methods, and I want to get the big listing of all of our deployed campaigns. So I'm going to call get deployed campaigns. When we call this function, it is a view function. Remember, we labeled it as being a view function. So here is get deployed campaigns. It's view. View means that we are not changing any data. And since we're not changing any data, we're going to call this function as opposed to sending a transaction to it. So this call right here is going to return an array of addresses, a big array. And it's going to have all the different addresses that we have for our deployed campaigns. Now we could certainly do something like, I don't know, const addresses, and then say like, remember we have this variable up here, campaign address, and as you might imagine, we want to stuff the deployed address into this variable right here. So we could say something like, campaign address is addresses at 0. Because this is going to return an array, we've only deployed one campaign, so we probably can assume that the one that we just deployed will be at index of 0 in that array. So if you want to, you can definitely write this line of code. Or we could be really fancy and use a little bit of ES 2015. Actually, this might be ES 2016 syntax. So you can do this if you want. Alternatively, we can delete the const addresses right here and replace it with square brackets campaign address, like so. So this is a little bit of destructuring from an array. We're saying that we want to take the first element out of the array that is returned by this thing and assign it to the campaign address variable. We are specifically taking out the first element because we are placing these square brackets right here. The square brackets tell JavaScript, hey, the thing that's being returned right here is going to be an array. Take the first element out of that and assign it to the variable campaign address. So again, this is a little bit of optional syntax if you want to get a little bit fancy. Okay, so now that we've got the campaign address, the next thing we have to do is create our actual instance of the campaign. So remember, the campaign actually exists on our local blockchain at this point, after running all the code that you see inside of here. Like there's some address, the contract exists there. And the address that it's at is campaign address right here. So now we need to write a little bit of code that's going to instruct Web3 to create a JavaScript representation of the contract, and that representation needs to be kind of operating against or trying to access the contract that exists at this address. Okay, so to do that, we're going to assign the result of this operation to the campaign variable. So eventually campaign will be the actual contract that we're dealing with. So I'm going to say campaign is await new web3.f.contract. Again, make sure you're using lowercase w, capital C. And then inside of here, we're going to pass in two separate arguments. First, we're going to pass in the interface or the ABI for our compiled campaign, just like we did a little bit ago with our factory right here. So the ABI for our campaign is on the interface property of compiled campaign. Just as before, this is JSON, so we need to parse that JSON before we pass it into this function. So as the first argument, we'll say json.parse compiled campaign.interface. And then as the second argument, we're going to pass in the address of where this campaign exists. So I'll pass in campaign address, like so. Notice how these two contract calls right here are slightly different. So we've been using this type of statement right here constantly throughout the course. We use this form right here where we do not specify an address whenever we want to deploy a new version of this contract. However, if we've already deployed the contract and we want to instruct Web3 about its existence, that's where we pass in the interface as the first argument, and then we pass in the address of the already deployed version as the second argument. So because this thing has already been deployed, we obviously do not have to execute the .deploy or the .send steps right here. All right, so I think that's it for our before each helper. I know there's a lot of code that went into there, but we're all done now. And at least we don't have to constantly replace or redo this logic right here inside of every single it block. So if we had not been assuming that, yeah, we probably need an instance of a campaign inside of every test, we would have had to like basically reproduce this code all over the place. And that, of course, would have been very annoying. All right, let's take a break here. We're going to continue in the next video where we're going to write out our first test. And then we're going to make sure that all this stuff works. So I'll see you in just a minute. In the last section, we finished up our before each helper. We're now going to add some tests to this file to test out both our factory and our campaign contracts. Before we add those, however, I want to mention one quick thing. I know that sometimes people get really tired of writing tests inside of a course. So if you are tired of writing tests and you don't want to write anymore, then feel free to skip this video and the next couple, and go ahead and skip ahead to the video on deployment of this contract. So again, if you don't want to do these tests, totally fine, I understand. Go ahead and continue on. Otherwise, stick around and we're going to write some tests. So here's my before each statement. Right underneath that, we're going to open up a new describe block. So I'll say describe campaigns, because that's what we're testing here. I think that a very reasonable first test will be to make sure that both the factory and the campaign were successfully deployed. And remember, we can test that by just asserting that they both have an address assigned to them. We've written this same test several times before, so essentially we're going to do the same thing as a nice little warm-up. So inside of my describe statement, I'm going to add an it block, and I'll say it deploys a factory and a campaign. And then inside of there, we'll add on an assertion to look at the options.address property of both the factory and the campaign. So I'll say assert.ok factory options address. And then I'll do the same thing for the campaign as well. Assert OK campaign options address. All right, so very easy warm-up test, but this is mostly just to make sure that our entire testing setup works. Before we run our tests, remember that we have to add in a script to our package.json file to run the Mocha test runner. I'm going to open up the package.json file. I'll find the script section. I'm going to delete the test script that is already there, and I will replace it with test Mocha, just as we had done previously. We can now flip on over to the command line and run the npm run test command to make sure that our tests are behaving the way we expect. So back over here, we'll do npm run test. And after a quick pause, we'll see our tests run like so. Okay, so you'll notice that it's still not an instantaneous process to get our tests running. So you might have been thinking, well, we're not doing the Solidity compiler anymore. They should be way faster. They are faster, but starting up that Ganache local network still takes a pretty good amount of time. So it takes maybe 1 or 2 seconds for our test to actually be executed. It definitely is way better than what we had before, where we had to wait for our contracts to be compiled at the start of every test run. So at least in that regard, things are a little bit faster. All right, so let's pause right here. We're going to come back in the next video, and we're going to add on a bunch of tests to our test file. In the last section, we added a very simplistic test just to make sure that our testing setup was working the way we had hoped. And it definitely is, which means we're now ready to add in a bunch more tests. That kind of puts us in the same situation that it seems like we are always in whenever we start writing tests. And that is, we have to start thinking about, what are we going to write tests for? Like, what are we trying to test here? Remember, I really advise you just sit down and think for a little bit about what behaviors you really care about inside of your code. Maybe something that we really care about is making sure that whenever we call create campaign right here, the person who is calling create campaign should be marked as the manager of the campaign that is created. So notice that accounts at 0 right here called create campaign. Because of that, I would expect this campaign instance should have accounts at 0 being marked as the manager. So maybe a good test to write right now would be something to just make sure that the manager of the campaign is accounts at 0. I think that'd be a pretty straightforward test to write. So let's give it a shot. Back down inside the describe block, I'll write out it marks caller as the campaign manager. In this case, when I say caller right here, I'm referencing the person who called create campaign on the factory. So I think that's a good description. We'll make sure we place our async keyword. As usual, do not forget that async, because we're definitely writing a lot of asynchronous code here. Then inside the it block, we have to think about exactly how we're going to do an assertion to make sure that the address for the manager is correctly set. I think that maybe we don't need to make this any more complicated than it is. Remember, we have access to our campaign instance right here. So if we call the manager method on the campaign, we can retrieve that address and then compare it against addresses at 0, or excuse me, accounts at 0. So let's give it a shot. I'll say const manager is await campaign.methods.manager.call. As usual, remember, whenever we make a public variable inside of our contract, a get method is automatically created. So you and I did not make a method called manager. This was automatically created for us because we had marked the manager variable as being public. So here's our campaign. Here's the manager. It is of type address, and it is a public variable. So that's why we have access to this method. And then of course, as usual, we are not modifying any data here. We are just retrieving the variable. And for that, we do a call as opposed to a send. So underneath this, after we retrieve the address of the manager, we can then compare it against accounts at 0. So I will assert equal, and we're going to write out what we want it to be, or what we hope it is, and what it actually is as the second argument. So let's save this and run our tests again. Back at the command line, we'll do npm run test. And after a brief pause, we have 2 tests passing. Very good. All right, well, that's definitely a good start. Well, that one came together pretty quickly, so let's continue on to writing our next test right away. Again, I want to think about what behavior I really care about for our contract. Maybe we should test to make sure that people are able to donate money to our campaign and thus become a contributor. So maybe we should use another account to donate some money to the campaign or contribute some money to the campaign. Then we can somehow check to see if that account or that address gets marked as an approver inside of our contract. I think that the first part of this test will be pretty obvious. We'll call the contribute method, we'll send in some amount of money, and we'll make sure that we are sending it from some specific accounts, from our accounts array right here. After that, we could then figure out exactly how we check to make sure that that person is marked as an approver. We'll get to that part. All right, so let's make another it block down here. So I'll say it allows people to contribute money and marks them as approvers. Don't forget to place the async keyword. I really can't say that enough. And then inside the it block, we can start writing out our method to attempt to contribute some amount of money to our campaign. So we'll say await campaign.methods.contribute. Remember that contribute does not take any arguments to it. Instead, we specify a value to send along with a transaction. Also recall that we have some minimum contribution level. For this campaign, we had set up a minimum contribution of 100. So we just need to make sure that we send in more than 100 way. All right, so we'll call it contribute.send. We'll specify a value of, how about just 200? That's totally fine. And then we also need to specify who is sending this transaction. So this is going to be the account that gets marked as the contributor or the approver. So we'll do from, how about accounts at 1. Remember that the accounts array is created for us by Ganache, and by default we get 10 different accounts generated. So this is just account number 2. Remember, 1 is the index. The first account is at index 0. So this is account 2 of 10 that we can make use of. This should definitely get us marked as a contributor, but now we need to figure out exactly how we make sure that the contract now considers us to be a contributor. This part's going to be a little bit more challenging. Let's go back and look at our contract source and see if there isn't some way that we can verify that this account address right here is considered to be an approver or a contributor. So back inside my contract source, I'll scroll on down to the campaign. Remember the data structure that we had used for keeping track of who is a approver. We went through all that long discussion about how we wanted to use a mapping for that, because mappings have constant time lookup, and it doesn't matter how many approvers we have, it'll always take the same amount of time to verify that someone is an approver. Also notice that we marked approvers as a public variable. So because we marked this as public, we do in fact get a method to access this mapping. If we call this approvers variable as a method or as a function in the exact same way that we did just a moment ago, like with manager right here, we don't get back the entire mapping. So we don't retrieve the entire mapping. Instead, what we can do is look up a single value in the mapping. In other words, if we call the approvers function that gets generated for us, because this is a public variable, and pass in the address that we want to look up, it will return a Boolean, either true or false. And so as we have set up our contract, we have said that if you put in an address and the mapping returns a Boolean of true, then you are considered to be an approver. So long story short, if we call the method approvers that gets automatically generated for us and pass in accounts at 1 as an argument, we should get back a value of true. And we can do that to verify that after calling contribute, accounts at 1 is marked as an approver. All right, so let's give that a shot. I'm going to say const is contributor equals await campaign dot methods dot approvers. So again, remember, this is the mapping. Well, more specifically, this is the function that allows us to access that mapping. We cannot retrieve an entire mapping, just does not exist. Instead, we can only retrieve or look up single values from it. So we need to pass in a key, and then this thing will retrieve or will return the value that corresponds to that key. So in this case, I want to see if there is a value associated with accounts at 1. So for the first set of parentheses, I'm going to pass in accounts at 1, like so. Now, as usual, we are doing data lookup here. We are not modifying any data, so we're going to tack on a .call, like so. All right, so isContributor should end up being a Boolean value, either true or false. So with that in mind, we can do a simple assert, and I'm going to assert isContributor. Remember that assert will fail if we pass in a falsy value right here. So if isContributor is true, the test is going to pass. Otherwise, this thing is going to fail. All right, let's save this contract file, or this test file, excuse me, and run it from the command line. So I'm going to change back over. We'll do npm run test. We'll wait a moment or two, of course. And sure enough, it looks like it actually passed. Very good. All right, so I think that's 2 additional tests that definitely add some value to our contract. Let's take a pause now, and we'll continue in the next section with a couple more tests. All right, my friends, we've got 3 tests done so far and still a handful to go. I think that the next test that we write should verify that a campaign has a minimum contribution tied to it. This will be a test that is very similar to one that we wrote for our lottery much earlier. Remember, with the lottery, we said there was some minimum amount that you had to spend to get entered into the lottery itself. And the same thing is true of our campaign. So let's write a new test out that's going to verify that. I'll place an it block, and we'll label this thing as it requires a minimum contribution. Don't forget to place the async keyword right here. And then inside of here, we can figure out how to actually write this test. We're going to use the same strategy that we had used back on our lottery. So we're going to place a try catch block. We'll then attempt to send in a contribution of less than the minimum contribution. And then we can use the try catch block to assert that an error did in fact occur. Now I want you to recall that when we created our campaign back up here inside of our before each statement, we said that the minimum contribution was 100 Wei. So all we have to do is call the campaign's contribute function and send in less than 100 Wei. And that should result in an error. All right, so let's give that a shot. Inside of our it statement, I'll first start off by placing the try catch block, like so. Remember, we're going to place the actual function call inside of try, and then we're going to really expect that we skip over everything else inside the try and go right on down to the catch. So inside of here, we'll say await campaign.methods.contribute. Remember that when we call contribute, we don't pass in the amount of money that we want to send here. Instead, we call .send, and then inside of this object, we specify the value that we want to send along with this transaction. So I'm going to specify a value of 5, which is obviously far less than the minimum contribution of 100. I'm then going to say that this is coming from accounts at 1, like so. So whenever this line or this function right here is executed, it should instantly result in an error, and we should then be thrown over to the catch block. To make sure that that is the case, underneath our function call, I'll add in assert false. So if this line of code is ever executed, my test will automatically fail. Then inside the catch block, I can add in assert error, And that's just going to make sure that, yep, we do in fact have an error object here. All right, so let's give this a shot. Back at the terminal, I'll do npm run test. We'll wait just a second or two. And sure enough, we now have 4 tests passing. Very good. All right, so that was a pretty easy one. Let's come back in the next video and work on a slightly harder test. We now have a test to make sure that people are allowed to contribute money and get them marked as an approver. We also have a test to make sure that we have a minimum contribution limit on our campaign as well. For our next test, I think we should start to move forward in functionality. In particular, I want to write a test that asserts that a manager has the ability to create a payment request. For this test, we're not going to try to actually approve or vote it or finalize it or anything like that. We're just going to say that we have the ability to make a request. So let's add on a new it statement. We'll mark this one as it allows a manager to make a payment request. This one is not going to be that bad. Remember that tied to our contract, so here's our campaign contract right here, we have a function called createRequest. We can call createRequest and pass in a description, a value, and an address. And that should basically make the request and add it to our requests array. So as step 1, I think we need to call the createRequest function and pass in these required arguments. So back inside of our test file, we'll write out await campaign.methods, and we want to call createRequest. CreateRequest is going to have several different arguments being passed to it. So just to make sure that everything is nice and legible for you to see it, I'm going to put this on a new line like so, rather than having this run all the way over to the right-hand side. So the first argument to createRequest is supposed to be a string description. So I will give it a string description of how about buy batteries. Like I need to buy batteries to make this Kickstarter campaign or whatever it might be. As the second argument, we'll pass in our value. So that's as a string 100, indicating 100 way. And then as a third argument, we have to pass in an address. We're not going to actually use this address to send any money to this account or anything like that. We just have to make sure that we provide an address in general. So as an address, let's just toss in accounts at 1. And of course, don't forget, I can't say it enough, and I know you're probably very tired of me saying it, don't forget to call send, because this is a function that it's going to attempt to modify our contract's data. We have to specify who is sending in this transaction, of course. The entire point of this test is to say that the manager is allowed to make payment requests, so we should definitely use the manager address, which is accounts at 0. And then as usual, we will also specify our gas. And let's remove our commas. All right, so that's going to make our request. Remember that anytime we send a transaction to a function, we get absolutely no return value back. So now we have to reach back into our contract after this thing is created and pull out the request that was just made. As usual, this is another thing that I'm sure you're tired of me saying. We made that request array to store our request. It is marked as public. That means that we automatically get a requests function created for us. One thing to keep in mind here is that array getter functions that are synthesized for us are only used to retrieve one element at a time. Because inside of our test file right here, we have not created any requests previously, that means that we should try to get the request at index of 0 from this array, because the one that we just made should be the first request in that array. So back inside of our test file, we can get that request that was just created by saying const request is await campaign.methods.requests. So this is our automatically generated getter for the array, and we need to specify the index that we want to retrieve from it. So I want index at 0. And as usual, we are not modifying any data, so we'll use .call. All right, so this is going to return our request. Remember, inside of our contract, a request is a struct, and a struct is a collection of key value pairs. So that request object that we just got back from that call should have a property description, value, recipient, complete, and approval count. It does not have an approvals method, or excuse me, an approvals property, however, because remember, whenever we try to retrieve a mapping, we can't get the whole thing. Like, we can't get everything out of a mapping. We can ask for individual values, but we cannot attempt to retrieve everything out of it in one go. So we have access to only these first 5 properties. Now, for the purposes of our test, we probably don't need to make an assertion about every single property of the request. So I'm just going to write one assertion, and I'm going to make sure that the description property of the request was set properly. So I will say assert equal, and I want this to be equal to buy batteries. And then as a second argument, I'm going to place the actual value, which is request.description, like so. Of course, if we wanted to, we could reference some of the other properties on the request, but again, we can just check for one and have reasonable a belief that, yeah, if this is set correctly, chances are everything else is too. All right, so let's now run this test. At the command line, we'll do the usual npm run test. And we've got another test passing. Very good. All right, just 1 or 2 more tests. So let's take a pause here and continue in the next video. We've got a good number of tests written out so far. I think we should do just one more test that really captures everything our campaign does from start to finish. So I want to take our campaign, I want to contribute to it, I want to create a request, I want to approve the request, and then finalize the request. And then at the very end, we should be able to assert that some other party received some money from the request. This is going to be a pretty good amount of typing for this final test that we're going to write, so let's get started right now. I'll add on a new it block, and I'll give it a description of it processes requests. We'll then place our async keyword and get started. So again, the first thing we have to do is contribute some amount of money to our campaign. I'll say await campaign.methods.contribute, and then I will attempt to send some money in, and we'll say that this is going to come from accounts at 0. To make this a little bit easier to test, we're going to send along a whole bunch of way, because generally it's easier to test changes in account balances when we are moving around large sums of money. If we're moving around just like 100 or 200 way, that amount of money usually gets lost in the thick of things when we compare it to gas prices. So if we want to make sure that we are moving around money, usually easiest to send along a good amount of ether. So in this case, I will send along 10 ether. And remember, anytime we want to specify ether, we're usually going to make use of the web3 module. So I'll say web3.utils.toWay. And I want to convert 10 ether into way. And I'm going to send that along with the transaction. Okay, so that looks good. Now that we have contributed and marked accounts at 0 as a contributor, we can now create a request. And in that request, we will attempt to send some amount of this 10 ether to another account. So right after this, we'll say await campaign.methods.create request. Now, just as before, I think request is going to end up being a kind of a long line with a couple of different arguments. So I'm going to new line it right away. Remember that create request takes 3 arguments: the description, the amount of money we're trying to transfer, and also the target account to send it to. The description doesn't really matter in this case, so I'll just put in A, like so. Doesn't really matter. But we do want to make sure that we specify an appropriate amount of money to transfer and an appropriate account, because we're going to eventually look at this target account and verify that it has received some amount of money at the very end of this test. So I'm going to say that I want to attempt to transfer web3.utils.toWay, and I'm going to try to transfer over 5 ether. So out of the 10 that I just sent into the contract, I want to attempt to send 5 of it to this other address. And in this case, we're going to attempt to send that 5 ether to the account accounts at 1, like so. Now we've only called create request. We have to remember to send it as a transaction as well. So we'll add on send. This will come from accounts at 0. And as usual, we will specify our gas as 1 million. So this right here should create our request to attempt to send 5 Ether to accounts at 1. Before we can attempt to approve or finalize this request and make the actual assertion, we have to remember to actually vote on this thing. So we have to attempt to call our campaign's approve request method and attempt to actually say, yep, this looks good to me. It can be sent. It can be finalized. Go for it. So before we attempt to finalize it, we have to vote on it. We'll say await campaign.methods.approve request. So remember, that was a function that we spent a pretty good amount of time on. Here's the function right here. So we call approve request, and we specify the index of the request that we want to approve. In this case, we've only created one request, and that request must be at index 0. And then, of course, we'll send this with this very repetitive statement. So we'll say from accounts at 0 and a gas of 1 million again. All right, we're almost at the end here. So now that we have approved the request, we can now finalize it. Remember, we can only finalize this thing because out of the one contributor we have, so here's finalize request right here, out of the one possible approver we have, they have already voted yes. So essentially 1 out of 1 people have voted yes on this thing, which means we can successfully finalize the request and have the money be sent to this other recipient. So underneath approve request, we'll do await campaign methods finalize request. Just as before, we have to pass in the index of the request that we want to finalize. So we're going to pass in 0, and we will send that in. So from accounts at 0, gas 1 million. Again, we are making use of accounts 0 here because in theory, only the manager has the ability to actually finalize the request. All right, so after calling finalize request, that should disperse the money from the contract over to accounts at 1. So now the last thing we have to do is retrieve the balance of accounts at 1 and verify that it does in fact have some additional amount of Ether inside of it. So the last thing we have to do is to retrieve the balance of that account. Remember, we can retrieve the balance of any account on the network by using await web3 eth get balance. And then we pass in the address that we want to check as the only argument. So in this case, I want to get the balance of accounts at 1. Now, just as before, when we call get balance, this returns a string. So we have to take the string, we have to turn it into Ether, and then we have to turn it into an actual number that we can use to make a comparison. So that's going to be maybe 2 or 3 lines of code. So I'm going to assign this thing to a variable called balance. And note that I'm using the let keyword here because we're going to do some reassignment of balance. So at present, balance is a string that represents the amount of money that accounts 1 has in Way. So the first thing that we'll do is we'll take that balance and we'll turn it into Ether. So we'll say web3 utils from Way, and we pass in balance and we specify that we want to have Ether. Now balance is going to be a string represented by, or that is representing some amount of Ether. And we can't really do an easy comparison with a string, so the last thing we have to do is turn this thing into a float. So I'll say balance is parse float, and I'll pass in balance. If you've never used parse float before, it's a built-in helper included with JavaScript. It takes a string and tries to turn it into a decimal number. So now balance should be an actual fully qualified number that we can do a comparison on. So at the very bottom, we can finally say we want to assert that balance is greater than some minimum amount of Ether that this account should have at this point. Now here's the tricky part. One thing that we have not been super clear on about Ganache inside of our tests so far has been exactly what happens to Ganache and our list of accounts in between tests. Inside of our test helper up here at the very top, we very clearly are redeploying our factory and our campaign between every test run. However, there is nothing at present that resets the amount of money that any account has between test runs. So in other words, we don't really know exactly how much money accounts at one should have at this point in time. Because if some earlier test said, hey, take all of this account's money and send it somewhere else, then at this point in our tests, accounts at one would have like 0 ether. In other words, we are not properly doing cleanup of our accounts list between tests. And unfortunately, that's kind of at present a limitation of the Ganache network that we are making use of. So ideally, we would be able to do a full restart between every test, but again, it's just not easy for us to do right now. So in other words, we have to be aware that accounts at one might have like, who knows how much ether. Now, just because I know exactly how these tests are working, I know personally that accounts at one at this point in time probably has around 99 ether or so. So just to make sure that my tests pass and allow for some float here, some changing of accounts one balance in case I ever come back in adjusting these tests, rather than saying that accounts one should have like greater than 105 or exactly equal to 105 ether, I'm just gonna say this thing should have like at least greater than like maybe 103. And maybe I could even do 104. And in fact, let's print out balance before we actually do that comparison and just kind of get a sense of how much money actually belongs to accounts at one at this point. All right, so let's run our tests and see what happens. So I'll do npm run test. We will wait just a second or two. All right, so right here, this is the balance of accounts at one. And you'll notice that it is not exactly the 105 that you might expect it to be. So in one of the earlier tests that we executed, I think we used accounts at one to issue a transaction. And when that transaction was issued, accounts at one had to pay for it in gas. So like I said, that gas that got paid doesn't really get cleaned up in between tests that we are running. Only the contracts do. So this is why we're kind of using that little bit more flexible amount that we are using for the comparison. That's why we're using 104 right here, rather than saying very rigidly, oh yeah, this account should have like exactly 105 ether at this point. Now in theory, we could use some other account besides accounts at one that we've never touched before, but honestly, that would just lead us into issues later on as we start to add on more tests, because maybe later on we start to make use of that other account, and maybe we start spending money or withdrawing money or sending money to it, and eventually a comparison between that account and 105 being completely equal would eventually fail as well. So we're just going to be a little bit flexible here and leave it to say accounts at one should have at least 104 ether. I know this entire system right here of comparison between accounts seems like it's very prone to breakage. Honestly, writing this test feels really bad to me. I don't really care for this one bit. But unfortunately, we just don't have a lot of workarounds or easy to do improvements here. I'm sure at the end of the day, we could think of some really clever way of handling this, but at present, we just don't have a lot of built-in functionality in the entire Ethereum world for writing the best tests in the world. Maybe at some point in time that'll change, but for right now, we're kind of stuck with this slightly more sloppy approach that you see right here. Okay, so at this point, we now have 6 tests passing. Like I said earlier, I'm sure we could think of dozens more tests to write. We could try maybe writing another test that says like, oh yeah, let's try to finalize the request without approving it. Or let's try to have someone who is not the manager approve a request, or not a contributor approve the request, or someone who is not the manager finalize a request, or any other number of test cases. So of course we could think of all these different types of tests to write. But at the end of the day, for the purposes of this course, I'm sure you don't want to be writing tests all day. So if you want to write more tests on your own, I absolutely encourage you to. I really, really, really encourage you to write your own tests, because it'll give you a much better understanding of how to make use of Web3 and manipulate the contract. But if you want to just move on to writing the actual application, which is pretty darn exciting, I will say, then feel free to pause here and continue with me into the next video. We've now written an ample number of tests, so the last thing we have to do on the Ethereum side of this project is to actually deploy our contract to the Rinkeby test network. Our deploy script is going to look very similar to the one that we wrote previously on our lottery contract. So I'm going to pull up that previous script that we put together, and I'm going to copy paste it into our current project. If you did not write out that script, or if you do not have that code still available, you can always go to this course's GitHub page and reference the deploy script from there. This course's GitHub page is linked in the second video of this course. So you can go back to the second lecture, and inside that thing, you'll find a link to the GitHub repo. All right, so hopefully either you have the deploy script from the lottery project, here's mine, or hopefully you have pulled it up on GitHub. Either way, we're going to copy the entire script, and I'm going to paste it into our deploy.js file inside the Ethereum directory. There we go. Now we can't just save this thing and run it because we've got a couple differences in our deployment process between how we wrote our deploy script before and how we are taking care of deployment now. In particular, we have to fix up the compile part of the equation. So the old deployment script assumed that we were doing the compilation on the fly, but now we are doing compilation as a separate step, and we now need to read the stuff off of the hard drive and then use that as a part of the process. The other thing that we have to remember to do is to install the Truffle HD Wallet Provider module into this project. So that was one module that we skipped during our installation earlier in this section. Let's first take care of that setup of installing this module, and then we'll take care of the refactor for the compile step. All right, so I'm going to change back over to my terminal. I'm going to make sure I'm inside of my Kickstart directory, and I'll run npm install -- save Truffle HD Wallet Provider. Everything's separated by dashes like you see. All right, so we'll just let that do its thing. Now let's take a quick pause. We'll come back to the next video and address the compile process. In the last section, we installed the HD Wallet Provider module at the terminal, and we're now ready to refactor our deployment script. In particular, we need to update the fact that previously we were doing compilation on the fly. So now rather than importing interface and bytecode from compile, we're going to require in our campaign factory JSON build. Remember that we are not deploying our campaign right now. We are only deploying our campaign factory. At some point in time, we'll use the campaign factory to create a new instance of a campaign. But as far as our deployment script is concerned, we are only ever going to be deploying the factory. So I'm going to find where we were previously requiring in the compile module, and instead we are going to require in the compiled factory JSON. So I'll say const compiled factory is going to be require build campaign factory.json, like so. So we're saying go into that build directory and find that JSON file, and then assign all that JSON to compiled factory. Now in the rest of the file, we shouldn't have to change too much. So the provider should probably stay the same. We don't have to update anything around Web3. All we have to do is make sure that we update the contract creation process right down here. So previously we were trying to parse interface because we were pulling in the the raw JSON from the compiler. This time around, we still have to do the JSON parsing, but instead we are going to be parsing the compiled factory's interface property. So in other words, we're going to update this to json.parse, and then we will say inside of JSON parse, compiled factory.interface, like so. Now when I save this file, I'm going to see all my code jump as my code formatter is going to try to make this a little bit prettier. So I'm going to save this, and okay, looks like that's what I end up with. So again, we want json.parse compiled factory.interface. Now if you left your code in kind of a messy state like me, you might still have a console log of the interface down here at the bottom. Let's be sure to clean up that console log statement because interface is no longer defined inside of this file. So I'm going to clean up that console log. All right, so I think we're now ready to try out the deployment. Now when we do this deployment, we're going to get back an address that we very much want to keep around because we're going to eventually use this deployed version in the actual version of our app. Of course, it's totally fine if you end up losing that address and want to redeploy this thing in the future. But for right now, hey, try to limit the amount of Ether you spend, right? So basically we just want to keep a hold on the address when we run this deployment script. So let's now do the deployment, and we're going to copy down the address that we get. I'm going to go back over to the terminal. I'm going to make sure that I change into my Ethereum directory. And then I will run my deployment script with node deploy.js. Remember, this entire deployment process, oops, looks like we've got an error here. So I think that we left bytecode in here somewhere. Right, that's my mistake. So right here, when we created the contract, we updated the interface, but we did not take care of the same thing for accessing the bytecode. So we can update this as well. We're going to say compiled factory.bytecode, like so. All right, so now let's try deployment one more time. So I'll say node deploy.js. And just as before, we're going to have to wait about 30 seconds or so for the deployment. So I get the attempting to deploy from account blah, blah, blah. And we're going to wait some amount of time to actually see the success message come up. And hopefully at that point, we should see the address of the newly created contract appear here as well. So again, I can't say it enough. You and I are only ever going to be concerned with doing deployment of the compiled factory, or of the campaign factory, really, because we only care about making sure that our users have the ability to create new instances of a campaign through this factory. Now you might be thinking, do we need the compiled campaign at all if we don't actually care about that thing? Well, remember, eventually once people start creating instances of campaigns, you and I will want to use Web3 inside of our web application to interact with those deployed instances of a campaign. And so yes, we do actually need this JSON file right here, because eventually we're going to need the ABI out of it so that we can work with those instances that have been deployed. So yes, we do care about both the built JSON files inside of here. All right, let's go back over to our terminal, and it looks like the deployment was successful. So here's the address of my newly created campaign factory. Now again, this is really important to keep this address around for right now. At the end of the day, it's not a big deal if you lose it, because you can always just do the deployment again, but I'm not going to explicitly show the deployment again in this course. We are going to redeploy at some point, but that's going to be to fix a little issue. So I'm going to copy this address right here, and I'm going to make a new file inside of my root project directory. And I'm going to call this thing address, like so. And I'm going to paste the address in there. Now this is definitely not something we usually do on production projects. This is just for the purposes of this course. I just want to make sure you have this address handy for when we need it in the future. So once we actually put this into a reasonable spot, we're definitely going to delete this file. Again, not a standard file to have in an Ethereum project at all, just for the purposes of this course. All right, so I think our deployment has gone fantastically. So let's continue in the next section, and we're going to start thinking about the web application that we're going to build.